These are the 5.5 notes for Algebra 2. We're going to talk today about functions. For example, number 1, we have our first function, f of x, which is equal to 5x. And our second function, g of x, is equal to 2x minus 3. So they're going to ask us three things for this one part, a, b, and c. Anytime you see f of x, like for example right here, you're just going to plug in what f of x is equal to, 5x. I like to keep that in a parenthesis. Then bring down the plus sign. And when you see g of x, you just substitute in what the g of x equation is equal to, 2x minus 3. Once you have everything substituted in, you add like terms. 5x plus 2x is 7x. And negative 3 does not have any like terms, so I bring down negative 3 minus 3. And that's my final answer. For part B, they're asking us to now subtract. So anytime I see f of x, I write a 5x. And when I see the g of x, I write 2x minus 3. Now when you have a negative or when you're subtracting, I like to put a 1 here and then distribute the negative 1. This leaves me 5x. And then I'm going to turn this into an addition sign. And I get negative 2x plus 3. Again, we call that distributing the negative. And then you're going to add like terms. 5x plus negative 2x gives me 3x. And then the positive 3 I just bring down at the end. 3x plus 3. Part C asks me to multiply. So f of x, 5x, multiplied by, and I'm just going to go ahead and take out the little dot and just write a parenthesis. Two parentheses next to each other always mean multiply. And then from here I'll distribute. 10x squared minus 15x. Example 2 gives us two new functions. So now our functions are f of x equals x minus 5, and our second function, g of x, equals x squared plus 3x minus 6. Part A asks me to add them, so I will put them in parentheses when I'm adding. And then I'm going to combine like terms. Combine like terms. I'm going to put them in order from the largest exponent down to the smallest one. We call that descending order. I'm going to bring down the x squared first, since it's the only one of its terms. I'm going to put a 1 in front of here so I can easily add the 1x and the 3x to make 4x. Then I will combine the numbers, the negative 5 plus the negative 6, to make a negative 11. For part B, notice how they put the g of x first. So make sure that you put your g of x function first. X squared plus 3x minus 6. Bring down the minus sign, and then you could substitute in the f of x function, x minus 5. I like to put a 1 right there. And just like we did on part B above, we're going to put a 1 here and distribute the negative. Bring down x squared, bring down 3x, bring down minus 6. That first parenthesis doesn't change. Then if we're going to distribute the negative, this inside sign would turn to a positive. Negative 1 times 1x is negative 1x. And negative 1 times negative 5 is positive 5. Then I will combine like terms. X squared is the only squared term. Bring it down. And then you're going to combine the 3x with the negative 1x to make positive 2x. And you're going to combine the negative 6 with the 5 to make a negative 1. And that would be your final answer for g of x minus f of x. Example number 3. This time they kind of wrote it out a little bit differently, but it's asking us to do the same thing. We have, again, two new functions. F of x equals 2x plus 3. G of x equals x squared minus 4x. And notice they are asking us to subtract them. That little minus sign right there. So I'm going to put my f function first, 2x plus 3. Put it in a parenthesis. Minus your g function next, x squared minus 4x. When we are subtracting, I always like to put a 1 and distribute the negative. That gives me 2x plus 3. I just bring that down. The middle sign would turn to a plus. And I distribute the negative 1. Negative 1 times x squared is negative 1x squared. And negative 1 times negative 4x, positive 4x. At the end, I combine my like terms, starting with the highest exponent, x squared. So I only see this 1x squared, negative 1x squared, so I'll bring that down. And I'm even going to leave off the 1 because it's not really necessary. A 1 in front of something is always invisible. You don't have to write it. Then I'm going to add my 2x together with my 4x, giving me 6x. Then I've got this 3 left over here. There's no other regular numbers, so I just bring that down as a 3. So we set it up, distribute the negative 1, and combine like terms. Example number 4. Again, two new functions, and they're going to ask us to multiply this time. So we're going to write x squared plus 3x minus 5 multiplied by 4x plus 1. All right. So I'm going to take this and I'm just going to distribute it. X squared needs to multiply by the 4x as well as the 1. So x squared times 4x gets me 4x to the third. X squared times 1, 1x squared, or if you'd like, just x squared. It's up to you whether you want that 1 there or not. Now we do the same thing with the 3x. So I'm going to erase these lines so I don't get confused. Switch colors here. You're going to multiply the 3x times both of these. So 3x times 4x, 12x squared. And 3x times 1, 3x. I'll erase those lines and do that in another color for the negative 5. Negative 5 times 4x, negative 20x. Negative 5 times 1, negative 5. And then I'm going to combine my like terms. 4x to the third. Check off that. Add the x squares, which would give me 13x squared. Got those two. Add the x's, so the 3x and the negative 20x would give me negative 17x. And then all that's left is to bring down the minus 5. All right, example number 5. Two new functions. This time we're going to multiply them, and then part B is going to ask us to divide them. Let's start with a multiplication. 4x to the fifth. And again, I'm just going to write those right next to each other in parentheses. This goes back to those exponent rules we learned. So we're going to multiply the numbers 8 times 4. But for our exponents, we are going to add them. X to the 5 plus 3. That would leave me 32x to the 8th. 32x to the 8th. For part B, I'm going to write the f of x on top, 4x to the 5th, the g of x in the denominator, 8x to the 3rd. And then I want to think about the 4/8 as a fraction. So 4/8 as a fraction can be reduced. If I divide each of those by 4, I get 1/2. So I'll write my answer as 1/2. And then for my x's, I ask myself, where are there more x's, in the numerator or denominator? There are definitely more in the numerator, 5 compared to 3. How many more are there at the top than at the bottom? How many more? That would be 2. That's a great answer. You might also see the answer written without that 1 in front. So I'll say, or x squared over 2, also a great answer. All right, our last one, example number 6. They're asking us to divide f of x divided by g of x, or f of x over g of x. Now for this one, this is going to involve us to think back to what we did first semester when we did factoring. Many of you learned factoring by doing the x method, trying to find numbers that multiply to 10 and add together to make 7. When you find those numbers, they'll go into parentheses just like that. They call those factors. So the numbers that work to multiply to 10 and add to 7 would be 5 times 2 makes 10. 5 plus 2 makes 7. Both of those would be positive. And then this x plus 2 at the bottom, we just kind of bring over. Now, because we have an x plus 2 at the top and an x plus 2 at the bottom, those can actually cancel out. And I leave a final answer of x plus 5.